I think recording started because I will put all my lecture on bright space. All right, so f is an antiderivative of little f if the derivative of f is equal to little f. Okay, so in calculus 1, let us see what we did in calculus 1. In calculus 1, basically, we started with a function f, and we actually concentrated on finding its derivative. Calculus 2, and we call this process differentiation. Calculus 2, we're going to move backward. It means we know the derivative. We know the derivative, and we have to find the function whose derivative is the thing we know. So this inverse process is called integration, or it's called antidifferentiation. Antidifferentiation. All right. So a function f is called an antiderivative of little f. So if I know the derivative here, f is called the antiderivative. Is when I differentiate f, we get little f. So a lot of simple example. So for example, find the antiderivative is, find the antiderivative of the function f of x equal x squared. Okay, so find the antiderivative of f of x equal x squared. So this means find the function. So I need to find a function f of x that has the following property. If I take this function and differentiate it, I get x squared. Okay, so that's what it means to find the antiderivative. All right, so let us remember how we differentiate. What's the main rule of differentiation? The main power rule of differentiation is the following. If I take x to the n, I differentiate it, what the derivative would do is take 1 away from the power. Now my job is actually to go backward. That's really what my job. So now my question is, what is the function? When I find its derivative, I will get x squared. Now, if I look at this rule very carefully, I know that derivatives take away 1 from the power. So this has to be 1 more. This has to be something like x cubed, because that's what this rule will tell me. And I'm basically reversing the rule. I'm actually going backward in this rule. So, but now I say, okay, but the derivative is n x to the n minus 1. So the derivative of x cubed is going to be 3x squared. So I need to compensate for the 3 here because I want only x squared. So I said to compensate for the 3, I'm going to multiply both by a third. So basically to compensate for the 3. So I'm going to take a third right there. And the derivative of this is equal to x squared. So f of x equal 1/3 x cubed. That's the antiderivative, because if I differentiate this, I get x squared. And usually the question is, can you give me another one? So can you give me another antiderivative? All right, keep going. Give me another antiderivative quickly. Give me another function. When you differentiate, you're gonna get also the same thing. Okay, chat is open. What?
1/12 x to the 4th.
No, I want an antiderivative for the same function. F of x equal x squared.
1/3 x to the x squared plus 1. It's a different part of it. Just x squared then plus 1.
I'm fine with that. I'm having trouble with that. Are you sure x squared?
Oh, sorry. X cubed.
Right. x cubed plus 1. That's also another antiderivative, because for the same reason, because if I take this function g and if I differentiate g, what do I get? 1/3 x cubed, its derivative is, we just figured it out, the derivative is x squared. And plus 1 is a constant, the derivative is 0. So the derivative is x squared. So 1/3 x cubed plus 1 is an antiderivative of g of x. And of course, we have a lot of other ones. So this is another antiderivative is, I can call it h of x. So it's another antiderivative is, let us say 1/3 x cubed minus 4, for example. That's also another antiderivative. The derivative of h prime is equal to x squared as well. And graphically, so let us remember graphically, why does this make sense? So graphically, what's really the picture? Graphically, the picture is the following. Suppose I take the function 1/3 x cubed. That's my original one. That's 1/3 x cubed. And let us do the following to it. Suppose I take this function and shift it up by 1 unit. I just take it and shift it. I don't do anything with it. I just shift it up by 1 unit. So that's my function g of x, which is 1/3 x cubed plus 1. I'm just shifting it up. Or let us say I shift it down. So I take this and I shift it down. Shift it. I mean, I take it and just move it. I don't really touch it. I don't really stretch it or anything. So this is my h of x. Now, what do we know about those three functions, which are a shift of each other? Watch those three functions. If I take any point x, any value of x, the derivative here, which is the slope, is exactly the derivative here, which is the slope, because those are shift of each other. It's exactly the derivative here, which is the slope. So all those functions, so this is the basic function, you can think about it, 1/3 x cubed, shifting it up and we shift it down, we're not gonna change the slope of the tangent line because those are parallel to each other. It means we are not gonna change the derivative. So if I have one antiderivative, 1/3 x cubed, I can have a lot of them. I take 1/3 x cubed and I add a constant to it, then I will create another antiderivative. So we can say that the function f of x equal 1/3 x cubed plus c, where c is a constant, is called the general antiderivative of f. Okay, so a function does not have one antiderivative. It has basically a lot of them, but not really a lot of them in the following sense. It has a lot of them in the sense that once we know one of them, we can get all the other by adding a constant. So that's how they are different from each other. So they are the same in the sense that they are only a translate of each other. That's how the antiderivative looks like, right? Okay. So in general, we have the following rule. So we have the following theorem. Suppose f is a function. A function. F of x, an antiderivative of f, one antiderivative. Okay, you have a function, you know one antiderivative. Then the theorem tells me all other antiderivative, so the function will have all other antiderivative have the form f of x plus c. Okay, so the theorem tells me once you know one of them, all of them will have the form this f of x plus c, where c is a constant. All right, So now we're going to move, keep going, of course, along the same line. The idea of indefinite integral. So what's an indefinite integral? Indefinite integral. Indefinite integral, so it's a symbol to represent antiderivative. In other words, we use the following symbol. Integral of f of x dx, the symbol, use the symbol, integral of f of x dx to denote the antiderivative of f. So instead of saying the antiderivative of f. And this symbol, this is called indefinite integral. And it has to do, of course, with the idea of the fundamental theorem of calculus. Indefinite integral. So what the indefinite integral is? So indefinite integral of f of x dx. This is nothing more than the antiderivative of f, where f prime is equal to f. So indefinite integral is nothing more than the antiderivative. It means the indefinite integral is a function. When we differentiate it, we get the derivative. So with this notation in mind, indefinite integral of x squared dx is nothing more than the antiderivative, which is 1/3 x cubed plus c. Because if I take 1/3 x cubed plus c and I differentiate it, I get x squared. All right, so indefinite integral is nothing more than the antiderivative. So now we're going to start remembering a lot of the antiderivative. All right. Let us say basic antiderivative. Basic antiderivative. Right. So we just saw that the integral of, so before we put the rule, let us remember. What the derivative do is take away 1 from the power, and that's crucial. So let us remember the basic rule. If I take the antiderivative of x cubed dx, what is equal to 1? So before we write the general, let us figure it out. Means what is the function? When we differentiate it, we get, for example, x cubed. Again, what's the function? When we differentiate, we get x cubed. Differentiation, take 1 away. So this has to be x4. Okay, what? x4, the derivative of it is 4x cubed. If I want x cubed to be my derivative, I basically have to divide this by 4. It means I have to divide this by 4. It means I actually need 1/4. That's the 1/4 coming up. So antiderivative of x cubed is 1/4 x4 plus c. And I can keep going along the same line. Antiderivative of x4 is going to be 1/5 x5. So what is the general rule for the basic antiderivative? So let us generalize it. If I have antiderivative of x to the n dx equal to, so of course I'm looking for a function. When I differentiate it, I get x to the n. That's really what I'm looking for. Differentiation tells me that you need an extra power, but that's good. But x to the n plus 1, x to the n plus 1, when I differentiate it, I will get n plus 1 times x, and I take a power away, xn. But I don't want this n plus 1 because I want only xn. So we have to divide by 1/n plus 1 to compensate for this n plus 1. That's really what this whole rule is coming from. So antiderivative of x to the n is going to be x to the n plus 1 plus c. Because if I take this and I differentiate it, I will get x to the n. But this is good as long as n is different from minus 1. Because if n equal minus 1, this is absolute nonsense. I will be dividing by my, if n is minus 1, I'll be dividing by minus 1 plus 1, which is 0, which is absolutely nonsense. So this is true as long as xn is different from minus 1. However, if n equal minus 1, what do we have? Antiderivative of x to the minus 1 is the integral of 1 over x dx. And now my calculus 1 tell me that the function whose derivative is ln is 1 over x is the log function. But it's actually the most accurate one is ln of the absolute value of x, because we will encounter situation where we will need the x to be negative plus a constant c. So this is the most important rule of differentiation that, of course, we should have totally under our belt memory. Now, there are some other basic antiderivative that you should know without really, just by heart, because they are simple. So I will ask quickly, what's the function whose antiderivative, what's the antiderivative of sine? And very quickly, I want answer on chat or just speak.
Cosine.
Cosine. Because the derivative of cosine is sine. True or false? True or false?
False.
False, because
It's negative sine.
it has to be negative. Why is that? Because the derivative of cosine is minus the sine. So the derivative of minus cosine is going to be the sine of x. All right, remember the derivative of cosine. The derivative of cosine is minus the sine of x. But now I want the sine of x. I want the function, when I differentiate, I get the sine, so I need minus the cosine. Okay, just to remember the rules. Then antiderivative of cosine, that's the sine of x, because the derivative of sine is the cosine. Remember, we are finding the antiderivative. We are reversing the process of differentiation. Now, what other important one? I need antiderivative of e to the x dx equal, quickly, just
E to the x.
e to the x. This one is itself. Plus c. Now, what other antiderivative I think we should know without any question asked, the one that you will forget? Equal. What is the function? When we differentiate, we get 1 over 1 plus x squared. Anybody remember that?
Is it tangent?
No, derivative of tangent is secant square.
The inverse sine.
The inverse
And
cosine. Sorry, the inverse tangent. Yeah, it's the inverse tangent. It's arctangent plus c. Okay. Remember derivative. I don't want you to confuse this absolutely with tangent. The derivative of tangent, actually, it's easy. We can figure it out probably tomorrow. What's the antiderivative of tangent? But let me remember the integral. The derivative of tangent is secant square. So do not confuse the derivative of tangent versus the derivative of arctangent. The derivative of arctangent, which is the inverse tangent, is 1 over 1 plus x squared. So do not confuse those two. Okay. So these are the most important, so because the derivative of arctangent is equal to 1 over 1 plus x squared. So these are the most basic antiderivative you will work with. Actually, one more, it will show up. 1 over the square root of 1 minus x squared. That's the arc sine. X plus t. Okay. So these are the basic one. Instead of xn, we will use continuously, and then the sine, the cosine, the ex, the 1 over 1 plus x squared, and 1 over the square root of 1 minus x squared. Those you should totally memorize, no question asked. So let us do a few exercises along those lines. So find the antiderivative or evaluate the following. Let us say integral of 1 over x squared dx. Okay, I will put them here and you guys do them in front of you. Okay. Please, when I ask you to do them in front of you, do them. And then we check the answers together, all right? So I want you to do all three of the, let's do one by one. Do the first one in front of you, we'll check it, and then we'll move to the second one. So you guys have a minute to do it. Please try to put your camera on because I would like to see your faces. Okay, Zach Richard, what did you get? Okay, anybody? I will usually asking you question, cold call. So I make sure you guys are working with me. Anybody, Emilia, what did you get?
I got negative x to the first, or negative first power.
Negative x?
To the, or 1 over x.
Negative 1 over x. Is she right? Okay, let's check her out. Step 1 is rewrite. So we have to rewrite it in the format that we actually understand. All right, 1 over x squared is x to the minus 2 dx. Okay, that has to be step number 1. Now I have it in the form integral of x to the n, where my n here is minus 2. So I'm going to use this verbatim. So this would give me 1 over minus 2 plus 1 x to the minus 2 plus 1 plus a constant c. So this will give me minus 2 plus 1 is minus 1. So it's minus 1 x to the minus 1 plus c, which is minus 1 over x plus c. And then you check. It means you differentiate this. You differentiate it, you should get 1 over x squared. If you don't, you're doing something absolutely false. All right, number 2, I also give you 2 minutes, and then I will ask you what did you guys get, okay? So number 2. All right, anybody like to share what they did? Anybody your answer, Ryan?
I got at 8 times the square root of x plus c.
Did? Okay, let's check him out. Anybody got the same thing? All right, we'll check it.
Yeah.
4 is a constant. So first we're going to rewrite it. That's 4 times x to the minus a half dx. Rewriting is always the most important step in the process. Okay, because 4 over the square root of x is 4 times 1 over the root x. It means 4 times x to the minus a half. That's the first step, rewriting. Now, 4 is a constant. That's a constant. Constant could be taken out. So, integral, actually, I will mention this rule again. I should have mentioned before giving you this problem, times this integral. So, this would give me that 4 times. Now, n is minus a half. So, this should be 1 over minus a half plus 1 x to the minus a half plus 1 plus my constant c. So finally, this would give me 4 minus a half plus 1, that's a half. So times 2 over 1, x to the half plus c, which is 8, basically root x plus c. So now I check my work. What do I check? It means I differentiate this term. And I should get that. If I don't, it means what I'm doing is nonsense. So this is equal to 8 is a constant. Square root of x is x to the power a half. So the derivative is a half x to the half minus 1 plus a 0. It means 4 x a half minus 1 is minus a half plus a 0. It means 4 over the square root of x. We are absolutely on the right track. All right? Okay. Now, before we go back to this example and more example, let us see some of the properties of the indefinite integral. Right. So, properties of the indefinite integral. Okay, the first property is the following. Even though I've used it a minute ago, but I have not to write it. So we know how to find the derivative of x squared, basically. The question is, what if you multiply x squared by 4? So we know how to find the antiderivative of x squared. What if you multiply it by 4? What, you create a new function. The question is, what happened to the antiderivative of 4x squared? So the property of the integral tells me the following. If, first property, if k is a constant, and the word constant is crucial, then antiderivative of k, which is a constant, times f of x dx is equal to k is a constant. The theorem tells me that you can take the constant and pull it out. So it's the constant times the antiderivative of the function. Very crucial. K has to be a constant. I mean, I repeat myself because it's crucial. Only a constant, like 1, 2, 3, 4. Constant, it means something that does not depend on x. The second property is the following. If I know the antiderivative of x squared, which is I do, and I know the antiderivative of x cubed, which is I do, I can create a new function by adding them. And the question is, what's the antiderivative of the sum? And that's a sum in here. Second property tells me the answer, tells me that if you're adding two functions, so you have f of plus g, The antiderivative of the sum is the sum of the antiderivative. Means if you have a sum, you can break it up. These are the properties. So we can break a sum, only a sum. What we can't do is break a product. So before I move on, let me make sure if I multiply two functions by itself, this is not the product. I cannot break up a product. I can break up the sum, but I can never break up the product. And this has to do with that the product rule is not the way we like it. All right? So I finished with one simple example, and then of course I will let you know. So let us say I ask you to do the following. Find the antiderivative of integral of like the sum 1 over probably 4 over x plus, let us say, 6 dx. Okay, so let's compute this. All right, first this is a sum. Since this is sum, I can break my integral. So that's the antiderivative of 4 over x dx plus the integral of 6 dx. Right. Let's see each one of those. 4 over x is basically 4 times 1 over x dx plus 6 times dx. Now, equal to. Now, let me make sure we understand. 6 is a constant. That's why I can pull it out. 4 is a constant, so I can pull out the 4. It's equal to 4 times the derivative of 1 over x is the ln of x plus 6 times. All right, here I was sloppy with the notation. So what does this mean? So let me make sure now I'm not sloppy. Let us understand that. What does it mean, dx? What does dx mean? It means when I write dx, what is the function I am talking about? It means what's the antiderivative of what? Can anybody tell me? So when I write dx here, usually I write f of x dx. And this means the function whose derivative is f. So when I write dx, what is the function that we understood here? Anybody like to tell me so we can quit? So what am I talking about?
1.
1, crucial. That's 1. That's really what integral of dx. It's really confusing. All right, it's really sloppy, but you have to understand it. So when we write integral of dx, what we really mean is that this here is actually the function f of x equal to 1. So what I'm really in the process of finding when I write integral of dx, I'm actually asking myself, what is the function? When you differentiate, you get x. That's what the notation integral of dx means. Now, which function we differentiate, we get x, sorry. My apology. Which function when we differentiate, we get 1 is x. So antiderivative of dx is equal to x. Okay, so integral of dx means, this is really sloppy notation, means integral of 1 times dx. That's the function we are talking about, which is equal to x. Okay, so with this in mind, integral of dx is 6x, and then we add 1 constant to the end. We don't have to add many constants. Right, so of course I stop here. So that's our first review. Please do the homework. The homework is 3 pages. I will tell you exactly on bright space up to which point I want you to do. And tomorrow we will keep going with indefinite integral, and we're gonna review substitution. So substitution is so crucial for us, absolutely crucial. I mean, we've done it last semester. I'm sure all of us did it, but we have to review it. It's the most important integration technique we will ever learn, and I wanted to learn it very well. Okay, so tomorrow I will review integration by substitution. All right. Okay, have a great semester. And as I said, please, if you have any questions, just talk to me. You know, don't shy away at any stage of your learning. And goodbye for now. Bye-bye, guys.
Have a good day.
Thank you very much. You too. Bye.
Goodbye.